Hello and welcome to our video on sections 8.6 and 8.7 of the Red Book on functions. So a function has to do with our x's and our y's. In particular, it's the correspondence between those two. And what's important about a function is that every domain or x value can only have one range or one y value. So in terms of a definition, a function is a relation, and we'll get to what a relation is later in the unit, where each input, or x, has exactly one output, or y. So no two ordered pairs should have the same first or x coordinate. So for example, if we have the coordinate -2, 3 and -2, 7, it would not be a function because that x of -2 should not have more than one y value. All right, so we want to make sure that we associate these three words. Domain with the set of inputs are the x coordinates. And the range is the set of all outputs, or the y coordinates. So every function will have domain and range. The domain goes in and the range goes out. So the reason we have a Pepsi machine here in this example is because we're going to reference what's called a function rule. In the rule, what happens is we put something into the function machine, if you will, and there's a rule that performs an operation, and then we get our output. So in the function rule in front of you, what happens is we put our input in of x, and it's going to then take that input, multiply it by 3, and add 5, and that will then in turn give us the output. So oftentimes you'll refer to this, or you'll hear it called a function machine. All right, so we're going to now look at some visual representations of functions. We have before us a set of data which has months and rainfall shown in a table. What we're going to do is we're going to write this three ways. First, as ordered pairs, which I've already done and I'll explain, then as a bar chart, and finally as a broken graph. So what we want to think in terms of, if we're going to write them as ordered pairs, is how would we number our months? And so of course we would think in terms of January is the first month, and February is the second month, etc. And so from that, we would be able to write the ordered pairs that you see here again, to represent the data given. All right, so those are our 6 ordered pairs. What we're going to do now is take that data and make a bar chart. So again, I've got the grid in front of me. Let's go ahead and make sure we can see those ordered pairs as well. And what we're going to do is we're simply going to think about the first month and think about the fact that it could have up to 12, or it has 12 inches of rain. So then we could go ahead and fill in the chart like that. In the second month, then we could look and see, oh, there's 15 inches. So I would be able to mark that, and then I could go ahead and, fill in. I did that. Actually, in these, we actually leave a space in between each, so that's what I forgot to do. And then in the third month, we would go all the way up to 21. So that's going to be just a little bit higher than the 20. And then I'm going to, again, just kind of alternate my colors. So I'll go back and use the green color, and then in the fourth month we have 47, so again just a little bit below the 50. And then finally, let's see, we have in the 5th month we're going to have 52. So that's going to take us a little bit higher than that 50 mark. And then finally, in the 6th month, we have 39 inches. So again, we're going to kind of get our upper boundary, if you will, and then a little bit less than the 40. And then we could go ahead and fill that in. So this would be an example of a bar graph. Next, what we're going to do is a broken graph. So here, in a similar way, I'm going to plot the coordinates, but notice here I used filled in versions. What I'm going to do now is I'm going to plot ordered pairs. So I'm going to plot the ordered pair 112, the ordered pair 215, 321, 447, 552, and 639. Then with a broken graph, what I do is I just connect those pieces. Now again, you could get out a ruler for this, but I'm just connecting those pieces to make the broken graph. Okay, so that is exactly what we're doing for section 8.6. Now we're going to move into section 8.7, which are functions defined by equations. So we first want to get familiar with a couple of different notations. The first is an arrow notation, which you see here in this example. We have P of n, where or such that the function rule would be 5 times n minus 500. That's one type of notation. A more common notation is functional notation. And this involves an equal sign where we have, again here, P of n, where we have these parentheses, is equal to, again, the function rule 5 times n minus 500. So our values of our function are, again, when we plug in values, we get out something. So again, this would be read right here, g of 2 equals 6. Or the value of g at 2 is 6. It means we're putting 2 into the function and we're getting out 6 from the function. In other words, the x is our 2 and our 6 is our y. So if we were to find the range of a function here, it means that we're putting in these individual values for the x. So if I plug in negative 7 to the function, then what I get is 3 times negative 7 minus 2. And that's going to give me negative 23 when I evaluate. I could similarly do that with 0, which is a pretty easy calculation. So that's going to get me f of 0 is equal to negative 2. And then finally, I could do that with the value of 5. Notice here we have a limited domain because we only are putting in 3 different x values. And 15 minus 2 is 13. So again, here when we put in 5, we get out 13. I'm going to do an equal sign here. And then, so again, our domain for this function would be what was given, negative 7, 0, and 5. Our range would be negative 23, negative 2, and 13. All right, so let's look at one more function where we're just finding the range. And again, in this one, I will actually list them. Let me go ahead and. So if we are finding the range, we are just plugging in these values. So f of negative 1 means that everywhere I see an x, I'm replacing it with negative 1. I'm evaluating this function for negative 1. So f of negative 1 is going to be, let's see, that's negative 1 plus a positive 1 minus 2. So that's going to be f of negative 1 is equal to negative 2. When I put in -1, I get out -2. And now we're going to do that for 0. 0 cubed plus 0 squared plus 2 times 0. Well, that's easy math. When I put in 0, I get out 0. And that's another ordered pair. And then finally, we're going to put in +1. So when I put in +1, I have 1 cubed plus 1 squared plus 2 times 1. And that's going to give me 1 plus 1 plus 2. So f of 1 is equal to 4. So my domain in this function was -1, 0, and 1. My range will be the numbers that I just found. So my range can be listed in a similar way as -2, 0, 4. And again, we have a limited domain, so therefore we have a limited range. Okay, so now we're going to find the values for each function with the set of real numbers as the domain. What that means is that we're not limiting the domain like we did in the last questions where it was just a particular set. We're saying that you can put anything into these functions. So based on that, we're going to evaluate for these different numbers. So again, I'm going to go through some of these fairly quickly. If we have f of 2, it means that we're going to have 3 times 2 minus 2. So that's going to give us 6 minus 2, or 4. And this is the notation we would use. If we're evaluating for f of -2, then again, we're replacing the x with -2, and we would get -6 minus 2, or -8. And here's our notation. And one more example here. If we're using this function, f of -4 is 3 times the input, which is -4, minus the 2. So we get -12 minus 2, which is going to give us -14. So we're going to skip the next example that's just showing another type of function, but where we put in input and get out output or range values, so that we can talk about one last type of notation. So next we are going to find two different values. In the first part, we are going to find f of 0. And that means that we're putting in 0 for the x. In the second type of question, we're going to solve for f of x equals 0. What that means is that we want to know what the x would be given that the y, or the output, is 0. All right, so let's go ahead and do the first. Here we are again putting in 0 where the x goes. So another type of evaluating. So 0 times anything is 0, minus 12. So we can see that we're going to get, when we put in 0, we get out -12. Now when we do the second part, what we're doing, we're saying that the f of x, this part right here, is equal to 0. So we're going to say 0 is equal to 3x minus 12. Now we're going to solve for the values of x that would make the y 0. And that's going to give us here x is equal to 4. Okay, so let's try that for another question. So in this one, we have f of x is equal to x plus 1 over x minus 2. And so again, we are going to first put into the function 0. So that's going to be f of 0 is equal to, again, this is a division symbol, so this is going to be 0 plus 1 over 0 minus 2. Well, that's going to give us -1/2. So when we put in 0, we get out -1/2. And then we're going to do our second type of question, which again, if we go back and look where we say f of x equals 0, we're replacing the y, or the f of x, with 0, and we're solving for the value of x that would make that true. Well, remember, if we have an equation like this, we can multiply both sides by the LCD, which in this case is x minus 2, to clear the fraction. And 0 times anything is 0, so what we get is just 0 is equal to x plus 1, and when we subtract the 1, we get -1 is equal to x. And that should make sense because we're looking for what makes it 0 in the numerator. Now again, we want to make sure that doesn't make it 0 in the denominator, and you can see that it does not. All right, so our last type of question is called composition. We will be doing more of this when we get to the Green Book, but this is our introduction. And sometimes this is referred to as nesting functions. But what we've got is two different functions with two different function rules. And we're going to put a value into one function and then put it into another. What you want to know is that we always work from the inside out. So we first will evaluate f of -2. We're going to get that output, and then we're going to put it into the next function rule. Now we have two functions that are defined. F of x is equal to x squared. So whatever we put into the function, we're going to square, and that's going to then give us our output. So here, when we're evaluating just f of -2, we're putting in -2, squaring that value, and then we get a +4. Now this output will become the next input into the next function, meaning that now that we know that f of -2 equals 4, we're going to substitute that value into the next function, which is the g function. So again, if you look and we're replacing f of -2 with this value of 4 because it's equal to f of -2, and then we're putting it into the g function. Well, the g function tells us that we're going to take our input and multiply it by 2. So we've got 2 times our new input of 4, so g of 4 is equal to 8. So our final answer here is g of f of -2 is equal to 8. We first put -2 into the f function, we get our output, and then we put it into the next function, the g function. So that concludes our video on sections 8.6 and 8.7 of the Red Book.